So guys, make sure to just uncomment the parts you need and try them out, try to understand them. And honestly, what we're trying to do is kind of getting a sense of how computers work, a sense how programming is done, a sense of what are the rules that it's there, what are the utilities, what are the what can we do inside programming, right? So the more we understand, the better we could use the tool, the better our life would be. Give you an example, a lot of people just with a hammer and nail, they could build you almost anything. And others, they'll need machinery, they need these bigger things, they need these other things. It's not always true, right? So if you master your tools, you could probably do pretty much anything. And whatever we're learning right now, we might not fully understand it, but we're trying to grasp a sense of it. And over time, as we practice and make more projects and more applications, you'll notice that all of this will become second knowledge, easy things, simple things, right? So I'll ask one last time. Anyone has any questions? If not, let's go to next thing. And well, we already made some classes from the previous course. The next part is again polymorphism, inheritance, all of this. But we're gonna dedicate that the whole of tomorrow for that. So for this part, we're gonna skip for a bit. We're gonna learn about some utility classes, some classes given to us in Java that will help us make our lives easier. So sticking back to main over here, there's a couple essential, let's actually write it here. There's actually a couple essential classes given to us, essential standard classes, I don't know, essential utility, whatever you want to say. Utility sounds good. Classes given to us. And this is important because these things will help us with our coding, making some stuff that we don't need to think about. One of those classes is, let's say, actually we had one big issue when our integers is, our integer cannot fit that integer, and we need to use this utility class which is called big integer, right? Other than big integer, we have a couple other ones. Actually, let's name some stuff. We have the math class, we'll try to use that. We have random, and we have a bunch of different dates. And there is inside Java, I think it was local date, local time, local date time, and there's other ones too. Okay, you could go look at that and so forth, so on. And there's a bunch of other things as well that could allow you to compare dates and so forth, so on. So there's actually a bunch of utility classes that's built into your Java, and depending on the JDK version, you'll get more or less, more power or less, or more tools inside your pocket. But I'm going to go through some of these, not all of them, really. Some that's useful, some that we might need to. The easiest one would be the big integer one. We talked about this, where our number was bigger than available value. So again, if we go back here, let's create a sample. Let's say an integer, big number, right? And again, well, actually, let's put some number here. Actually, 1 second, we'll put 0. And again, we've got to remember that an integer is 4 bytes, and each byte is 8 bits. So having that many bits, what's the biggest number we could go to? And remember, that's the power of 2, right? And again, if you don't understand what I'm talking about here, go back to our first video, and we'll go through that again. So again, we need to put something that's too big. So we could put some big number. Sorry for my French there, but we want to put a number, but it's a bit hard to read. So one of the key factors that's helpful is to put those underscores, right? So we're gonna put, let's say 1 underscore 30. So now we're at 1000 underscore. Again, the underscores are decoration. They don't do anything else than make it look easy on our eyes. So we're at 1 billion. Let's see if that's big enough that it won't be shown correctly. So if we do print too big of a number, and if we print that out, what's going on? Too big of a number, and here what we have 3 zeros, 6, 9. So this is still good. So let's add another 3 zeros, and you'll notice already the IDE is helping us out, saying, hey, this integer is too big for an integer, right? So this is the cool part about having compile time, so we don't make these mistakes. And this could have also happened if we did like a multiplication. So rather than saying this, you know, this would not be an error, right? But if I multiply this by 1,000, well, now the number will be too big, right? So that's an error they can't catch during compile time. So this is a runtime error. Well, actually, it's even worse than that. It's a logic error, where compilation didn't give us any errors, but the result given is completely off. Everyone sees that? So the worst thing that could happen, a logic error. Okay, so the first thing we could do with this is to have this class that enables us to get even bigger numbers. So we could say big integer over here. Let's say bigger number. Again, horrible variable names. And again, this is not a primitive type, so we have to create it. And we have to give the initial value in this case. So we're gonna take, I think that was the way to do it, yeah. So we're gonna give it the big number. Can that work? I don't remember the syntax, just give me. So let's go to big integer. It takes bytes, it takes arrays. Okay, actually, if I remember correctly, we could do something like this. Big integer dot value of, now we give it a big number. So we give it big number multiplied 1,000. And this should work. Okay, and then we could also increase that and do all those funky stuff. So now if I print this here, well, actually we're gonna leave this number here, but if I do it again, and here we're gonna write correct, correct number, okay, and we will print out bigger number. Right? So this time if I run it, first time it's still going to give me minus weird numbers, but the second time, it's not doing it correctly because of this. Okay, you know what? Let's give it the big number first. It's because the initial value given inside that parentheses was still too small, right? So afterwards, we're going to see if we could do. Here we got division, so we should have multiply, right? GCD max mod multiply. There we go. I'm gonna multiply it by 1,000. Okay, so if you ever give something, you need to give it the correct. We need to provide another big integer. So let's say big integer dot value of 1,000. Okay, again, you gotta learn how to use it. I don't use this at all. I don't use Java. Now if we run it, you'll notice we have the correct numbers. 3 zeros, 6 zeros, 9 zeros. 3, 6, 9. Actually, isn't it the same thing? 3, 6, 9. It's the same one. They didn't make a mistake. This number multiplied this should have been 3 more zeros, right? Maybe this, okay, this is returning a function. Yeah, so this is being ignored. The number is not changing. So what we should have done is grab this part and put it here. And now it should show the correct numbers, which we get 12 zeros. 3, 6, 9, and 12. Again, helper classes are there. You just need to learn how to use them, which I did not. So don't do the same thing as I do. Do as I say, not as I do, which is the worst thing. Cool? So anyway, that's big integer. Math becomes even cooler because in math we could do funky stuff. You could just use the static class of math. So in this case, notice everything is static. The reason it being static is because they don't need each other's value, right? This object doesn't need to stay in existence to do the absolute number of this, or the add exact, or comparison, like the floor of this, or the max of this, or the minimum, or etc. There's a lot of functionality in this, and one of them, the cool part is you also have random, you have power too, you have next, and all that. And let's say power, for example, where you're given the base, let's say 2 to the power of 3. And actually, you know what? Let's surround this by math dot power of 2 to the power of 3. We get 8. So this would be 2 times 2 times 2, right? So 2 times 4, 2 is 4, 4 times 2 is 8, so that's correct. We got a good answer. And now I'm wondering, again, notice a couple things that we need to notice before we move on, is the function does only what it's stated and nothing more, nothing less, right? And we don't see how it does it, so we're not seeing the body at all. We're expecting it to work correctly because we're expecting them to not do more or less than what the function name is supposed to. So this is an important thing. Okay, so another cool thing we could do is hold down Control and click on the POW and actually go see how they implemented and see comparatively to our own code what would have been different. And notice here they're calling another part of their code. Let's go look. And notice over here they're calling another part of their code, and notice over here it's a bit too hard to read and we could ignore it, right? But they're taking care of a lot of stuff and they're trying to do it, and you could look exactly how they do it. And in their case, they're taking care of infinities and all that stuff. They're taking care of every part of making a power. To be honest, if we would have made the power, we wouldn't have taken care of any of those things. We would have just taken care of doing a for loop that goes through it and does multiple things. If you notice what they're doing is they're actually manipulating the bits to make their code much faster, and hopefully later on you'll come back to this and this will make sense. Later on being not with me, the next semester, because I'm not going to teach you anything with bits manipulation, but it's something cool to do because this is much faster than doing a loop as an example, right? Any questions? All right. So there's that. There's math. Again, use all the other functionalities. There's really cool ones. Math dot, let's say, get the max number out of two numbers. Which one's the bigger number? Okay. You don't need to rewrite these codes because it gives it to you. So what's the, let's say these two numbers was given to us by the user, right? So this is why it's a utility, right? Stuff that's, you could have done the max in a second, right? You do an if statements. If you go look at the code, there you go. It's just, we're using this because it's clean, right? It's readable and it's given to us. We don't need to rewrite it, right? Again, the bigger number here would be 5. Cool. So there's a lot of math stuff like the floor, the ceiling, the maximum, the minimum, the blah, blah, blah. You could go through the list yourself, figure out which ones you need, etc. Now, there is another one that we want to use, and this one is called the random. Okay? And just one second. So the random, so again, actually, if we go at this and we do math.random, and we have a math random that's there. And the problem with the math random, oh, it's actually not bad. It's pretty well done. second. This one. So actually, this is a pretty cool random number. It will always generate you a number between 0 to 1, right? So this is a good thing to do. There's also, before we use this again, so generates a number between 0 to 1, right? Before we use it, I want to show you another class, and then we'll come back to this again. So the other class is called random. And we're gonna create a random, and inside the constructor, inside here, you could give it a seed, and this seed is like to use this to determine what the random value is gonna be, and this is important. If you don't use a seed, you're gonna see what's gonna happen. Let's say here, first of all, let's divide these so we could kind of see what's going on. Over here, if I want to get a new random number, I would do random. Next, let's say, this is the cool part about using this class. You could get Boolean, double, float, Gaussian, whatever you want. In this case, let's say an integer, right? And let's do this line a couple times. Copy, paste. So let's see the values. You'll notice after, actually it's a pretty good seed. And not having a seed, I think it uses the default, creates a new random generator. The constructor sets the seed of the random number to a value very likely to be distinct from any other. Okay, so the functionality, well, actually it's using the system nano time, which is what we would have done, is if you give it a specific seed, it would use that for its formula to get you the next value. And this is important to use this. Well, it's important to give it a correct seed that won't mess up, especially for the math in this. Actually, you know what? Let's do both of them. And you're going to see why this is important. Actually, I'm wondering one second. Sorry, it's been over time, they changed the codes and they become better. Back in the day, you had to, if you would have done 4 of these in the same time, it would give you the same values every time, right? Because the seed is too close. In the case of both of these, we're seeing that the values are always different. So to be honest, we could end it right there and we got our random, which is great. Yeah. Well, let's see. Okay, so sorry about this. I should have looked into this before starting. So in this case, we have 2 randoms that works out perfectly for us. But the numbers are really funky. Okay? Now, if we want to put a limit to our next int over here, I saw it while I was typing, you could give it an upper bound. So let's say from now on, all these numbers, I want it to be 100. All right, and if I run it again, it's going to give me values between 0 to 100. Okay, so the bound gives us our maximum. Maximum by the parameter bound. Right? And if I wanted to give it a minimum, so this time I don't want it to start from 0, because every time I run it, it could be any value between 0 to 100, 79, 37, 30, 90, 61, etc. I could give it a minimum by doing the plus. So plus, let's say I want it to be between 5 and 105. So this, you got to be careful with this, because this also brings your maximum a bit higher. So let's say if I add this over here, notice that 99 would be 105. So let's run it a couple times. Hopefully we get a number that's at the edge. First of all, you'll notice there's no numbers that's going to be less than 5. And you're going to also notice that sometimes you might get over the number, because this increases whatever value between 0 to 100 we get, plus 5, right? But this is good to get a minimum. Now, what's even more fun, well, this is also why you want to kind of use a seed to make these numbers in the lower end. Actually, I wonder what seed people would use. Let's see. Let's Google that. Java math.random. And if we go inside Stack Overflow, the place we always go. So, actually, they're using math random. Let's go ahead and use that. Okay. Anyway, if you use a seed, you could get lower numbers and decimals. In this case, notice that our boundaries are built this way. Let's say if we get the math.random numbers, you'll notice it's always between 0 to 1. Because it's between 0 to 1, we could manipulate it a bit more. So let's do something. Okay, let's make a new line. This case, I want to create, well, let's first of all go math.random. So the first thing we'll notice is we're going to get a random value. Okay. If I want that random value to be between minimum, well, if I want that, how should I say? So if I want my random value, let's say if we multiply for 1 second by 10. This is going to give me a value. Let me copy this. This is going to give me a value between 0 to 10, right? Maximum number would be if I get a full 1. A full 1 will give me a 10, right? 1 times 10 would give me that. Anything else would be 0, but because of the 10, it will push the stuff left by 2. So this, actually, let's do something. Let's do a for loop. It's going to make it more sense. And let's say position, I don't know, 0. Position is less than. How many times we want to repeat the for loop? Plus plus position. Okay, let's grab that, put it in here. Now, in this position, I want to grab that number. So this is a big double, right? Math.random returns us a double. Okay? So double random number equals math.random. Random number plus final number. And in this part, we'll keep the same now. We don't want to regenerate a number. We're just going to do random number times 10. So this number is going to become that. So by doing the multiplication, we're giving it a upper bound, right? So 0.88 becomes 8. And what we could do is say math dot and use one of these things to take away the, we could floor it, or we could whatever, let's see, what do we have here? Sorry, I'm forgetting the words. Next, we could round it. There we go. Right? So now if you look at that, our number from this, we multiplied it, it became 40, well, it became 4.8. From the 4.8, we rounded it, and we got a perfect number, 5. And this number is always going to be between 0 to 10, right, because of the rounding. So far, so good. So we created a number with an upper bound. Now, what if we want to have a random number between, let's say, 5 and 10? So we want to keep it to 10, but we want to have it with 5. So in this case, we would add 5, right? 0, 1, 2, 3, 4 will become 5, 6, 7, 8, 9. But the problem will become that if we do 10, then 10 will become 15, and we don't want that, right? So let's test it out. So you'll notice now it's going to make a mistake. We got the minimum, lower bound, we got it to 5. But the upper bound is not bound by 10 anymore. It's now actually bound by this weird number. Actually, it's even worse. Math.random plus... Why is it 35? Random number times 10 plus 5 gives me that. Why is doing... Oh, sorry, it's because it's text. Okay, that makes sense. Because this is string concatenation, it thinks this is a string plus a string. Okay, so I was seeing it. So we're gonna put it inside our parentheses. Actually, you know what? This we could either put it on inside parentheses, like this, and that would work out fine. You'll notice now we get numbers and it's going upper bound. But let's go ahead and bring this into its own line. So we're gonna create integer final, let's say number equals whatever that was, and we could take off the parentheses. So we make our code look a bit cleaner. And over here, we could just say final number. And we don't need this parentheses. What's going on? Whatever. Don't really care about this. This provided. Okay, because math round gives back a long, and long is anyway. And I forgot to put the parentheses here. Let's run this quickly. What happened? Run my application. So now if I run my application, you'll notice all the numbers are always going to be between 5 to 15, right? The lowest bound 5, the highest bound 15. Run it again. Again, we always want to test out our code, so we make sure our code is correct in the way we want it to do. So this minimum is working. So this minimum is working. But our maximum is not, and this is a problem. How do you guys think we could fix this? Well, again, this is where we want our math skills to come back, the minimum math skills. So we got this multiplied this, which gave us a value between 0 to 10, which is good. And then we rounded it to whichever nearest number is, and then we added a minimum. But we can modulus this by the maximum. So in this case, we want it to be, we wanted the number to be by within 10, but this is going to give us another error, you're going to see. So modulusing all of this number, actually, I'm going to go towards the answer over time. Still wrong, but I hope it makes sense to you. If it doesn't, you let me know. So over here, again, parentheses first thing inside, we get a random number, which is this. And then we multiply it by 10. So we get 2.041. Okay. Then we round it up and it becomes 2. Okay. Then we do, so we round it up and this becomes 2. Then we say 2 plus the minimum, which is 5. It becomes 7 here. 7 modulus 10, which is saying grab as many 10s as possible and give me the remainder. Well, there's no 10s, so the final value is 7. And in this case, it's fine, right? We got our numbers between our 5 minimum and our max 10. But if we go to the next number, now it's going to get interesting. Let's do it again. Random number gives us the 0.67. Multiply that by 10, we get 6.7. Round that up, we get 7. So here right now, we're at 7 with the math round. Now, 7 plus the minimum gives us 12. We're at 12 now. 12 modulus max, which is 10, says take as many maxes as you can and give me the leftovers, the remainder. This will give us back a 2, right? So now we got our maximum, which is 10, and we got our minimum. Well, sorry, we had our minimum, but now the minimum doesn't work. So, anyone has an idea on how to make this work?
If block, sir.
A block? What do you mean? What do I do?
Yeah, if block, sir. If number is smaller than like minimum, then don't do the modulus max.
Yeah, that's actually a good solution. That's perfect. So here, what he says is we could branch off. If the number that we're given, so this final number, rather than directly doing that, let's create first a long number. So the problem was the modulus, right? Actually, you know what? Oops. Let's take off this now. So rather than doing a max here, we could do an if statement and say if final number is bigger than our max, then we make final number equal final number modulus step. Actually, no, sorry, yeah, that's correct. Right? But if we do that, we also need to add the minimum again. Is that what you meant?
Yes, sir.
So again, we're not positive. We always want to test out. We run our code. We get values between 10 and 5. So we run it again. Run it again. Now it seems to be good. I'm seeing every number. 5, 6, 7, 10s, etc. Right? They're a bit more closer because the range of numbers we get is between 5 and 10. What if I said the range of numbers is between 50 and 100? So our random is not good anymore, right? This is why we want to test that as many times as possible. What do you guys think? What should I do to fix this? Our random numbers are only showing between these numbers.
I think it's problem with mod 10. Final number mod 10.
So what should you want me to do? Mod 10 over here. Ah, that should be max. Sorry. Let's do that again. Still no good. What do you want me to do? Well, okay. So this formula, there's a few issues. The problem is, well, actually, we could ignore this part. The problem with this formula is this number over here where we're multiplying it. This is fine for multiplying. The problem is we're always multiplying it by 10. So over here, a better idea would be to give it the max. But if we do that, we're still not going to get the issue, the solution we want. See, we're getting really weird numbers. We want the max to be influenced by the starting number, right? So if we start at 50, we don't want the maximum number to be 100 because that's 0 to 100. We want the maximum to be from 0 to 50, right? I don't know if that makes sense. The range, this, if you remember correctly here, when we're multiplying it, because this random number gives us a number between 0 to 1. So if we get 1, we get the maximum 100, right? But if we get, let's say 1 or 2 or 3, we don't want those numbers. We want it to be between 50 to 100. So only numbers I want to multiply by is 5 to 10, right? Or in this case, 50 to 100. So what you need to do is to actually say max minus min. And I know I'm explaining it really bad. And usually I would say when you explain it bad, you don't understand it completely. And I just need to draw it out. It's a pain in the butt. And anyway. And you have a lot of videos online you could go check. They're much better than me in this part. Okay? So the problem was actually this multiplication over here. We were giving it a range from 0 to 100 when we should have gave it a range from the minimum to the maximum, which is 50 to 100. So in this case, in this case over here, actually let me go grab the pens, that's gonna make it better. So over here, what we're doing is we're decreasing. So 100 minus 50, right? So this range, this multiplication is gonna just go to 50. So what's gonna happen is this random number is gonna be anywhere between, so in this case, this random number is gonna be anywhere between 0.50. And then in the next scenario, over here, this plus, so this rounds it up, let's ignore that, but this plus increases those values. So we got a 0 to 50, well this plus will make this into 50, and 50 plus 50, this would make it to 100. So now we're enforcing that our random number will always be between 50 to 100. And this is interesting because we could do really cool things with random number. Does that make sense? I hope it does. The random number, you could Google it, try to understand it a bit better. But if you start seeing our numbers are always going to be within the range we just set. Right? So this max min thing, it's more to think about the range of our numbers could be. And in this case, the range is decided by max minus min. Right? And because we have the range, we multiply the variable that we got, the value that we got by the range. And then we add the minimum to start the range from 50 rather than 0, because everything starts at 0. Right? Any questions? And the cool part is, you know what? Well, these are the stuff that we could have sent. Refactor, send it to a extract method, and we could have got, say, random number, which takes, well, we don't need a random number. Could have said it takes a minimum and a maximum, and it's going to give you a random number between minimum and maximum. So we refactor this, and now look at that. Random number, minimum, maximum, and it would give you a good number. Run it. Oops, we got an error. So there's a mistake here. It doesn't refactor perfectly. So in this case, what we want to do is create a random number. So actually we don't need this line. We're going to do math.random, which gives us a random number. We multiply it by the range, which is the maximum minus the minimum, and we add the minimum. Right? It's the same code we had. Actually, if you want, and actually long random number was here, and this was math.random. What's the issue? Required double actually, sorry. And over here we could say random. Cool. And again, even though it has the same name as the variable name, it's fine. Okay. Or a better name here would be, because I went and said, you know, have verbs at the beginning, so generate random number. Now this prints like this. Cool. And now we don't even need these. Even cooler than that is we could just plug and play, and here we put, let's say, position times 10. I don't know, let's try it first by position, and position plus 50. Or actually, you know what? Let's just do 100 and 50. And this random number over here we don't have, so just say it paste. And we make sure of all our stuff works, so run it. And you'll notice we're getting numbers between 50 and 100. Cool? And this could be useful because I might ask you to, hey, randomly select a person from this list or from that. And this is a really useful thing to understand. The minimum, the maximum, etc. Cool? Any questions? All right. So the last, well, I don't know. Yeah, the last thing we want to talk about. Let's put this down here, and tomorrow we'll start the more polymorphic stuff. Refactor, random stuff. Okay. The next thing we want to talk about is we've been using. Actually, we're going to go to this other class. We've been using arrays a lot. And if we remember, arrays are what? Mutable or immutable? Whoever's listening to me. Arrays are what? Immutable or mutable? I didn't hear anything.
Mutable.
No, arrays are not mutable. Arrays are
Because
immutable.
we can't change.
Because, as one of you was about to say, is when they're written inside the heap memory, so when they're giving a space inside the heap memory, so let's say over here you have your Chrome, over here you're watching some YouTube video, right? And it notices that you have enough space, change the color, you have enough space here to allocate for your array. Okay, whatever that size may. And when you're given that size, if you try to go bigger than the size, so let's say if we look at this size, it's currently a size 5, right? 1, 2, 3, 4, 5. So currently the size is 5. If at any moment I try to go more than 5, well, I'll be intruding inside Chrome, inside my neighbor's area, right? So this is why this is immutable. It cannot resize because next to it, the memories might be used. So the general rule is, if you want to resize, you have to reinitialize. You have to create again another array. And on the heap, it will look for somewhere that has more space and give you that new location. Right? But by doing that, you also lose all the values you have inside your array. Unless you create a temporary array, you transfer everything, and then you put that new array as your value. Right? Everyone with me so far? So you might as well do a bit of funky stuff. So let's go back here. So let's say we have a max students, and let's say we don't want it to be determined anymore by being finalized. We don't want this to be the final number for our max students. We want our students, actually, I don't want to change this because I did an example of exception with that. So we're going to keep that like that. Let's go to another class. Let's go to students. So notice inside student currently, we have only 2 courses, right? And we could add courses. Well, this is kind of public. Let's make it private. So if anyone wants to add to course to a student, they will have to call our function to add. So let's say I'm going to create a getter and setter for it, but this one is going to be a bit different. The setter is, I don't want people to create me an array. I want them to be able to add to my array. So we're not going to set anything. We're going to call a new function, add. Do I have one? No. So I'm going to say public void add course. And we're going to pass in the course. Right? So any courses that they add, I need to track which locations they'll be added. So here, I need to also keep a tracker of how many courses I currently have. So I'm going to create another variable, call it integer total courses. And currently we'll set it to 0. right? So here, when I'm adding a course, I just have to say course, add position, total courses equals that. And then I do total courses plus plus. And I seem to have an error, so this is courses with an S. It's plural, it's an array, not the singular thing. So I hope you notice the plurals and the singularities. This is important because an array is usually shown by this last letter here. Cool? Any questions so far? So here we're adding courses, but at some point we're gonna reach our max courses. So how do we know this? We don't, because it's not stating anything, right? So what we could do, if we wanted to have infinite courses, rather than adding a new variable saying maximum courses, we could say over here, if, well, we could do a bunch of things. So if, so he's trying to add a new course, and I say if currently the total amount of courses is bigger than or equal to, well, it's always going to be equal to, but we're going to say bigger than or equal to courses dot length, right? So currently the length is 2. Total courses is going to start at 0. So position 0, then goes at 1. And when it becomes 2, it's going to be the same amount as my course length. So the amount size of my array, right? Let me just draw that down. So if we had an array currently of size 2, well, let's say, so actually let's do a smaller one. So if we have currently an array of size 2, just like this, the position, the first position is going to be position 0, then it's going to be position 1, right? But the length of this is going to be 2. Same thing if we had something bigger. Actually, let's make it into lines. So 0. Okay, so let's say this. The positions are going to be 0, 1, 2, 3, 4, and 5. But the length of this is going to be 6. So when we're adding a course into, or a value into one of these parts in the array, we have to say the current location. So the total course starts at 0, adds in a course, then it increases, it goes to the next one. Total courses adds a course, then it increases, goes out here, it becomes the value of 2. 2 is the length. So this is why I say if the total amount of courses equals, in this case we say bigger than or equal to courses length, then it's the moment I know that, well, I can't add more courses, I'm at my max. So I could either throw a new exception and let the next guy handle it. No more spaces for courses, right? You guys agree? And again, you gotta remember, we gotta say it throws our application, sorry, this function throws an exception, and this will be fine. Or we could do something even better. We could say, well, you know what? I'm gonna fix that issue. I noticed that courses reached its maximum size. So what I'm gonna do is I'm gonna create a new array of courses, right? And I'm gonna make it double the size. So here I'm gonna say course, the size of it is gonna be courses dot length times 2. And this is a perfect thing. So now if the size was 2, well, now I'm gonna make it the size of 4. And the moment it reaches the maximum of size of 4, from 4 I'll make it to 8. Right? I could have also made +1, but that's be annoying every time to increase it by 1. This would have been fine either way if you did it +1 or times 2. Right? But we can't just finish there. We got to make sure that we copy everything inside our courses into this temporary course. Because again, it's a new location in the memory. So I'm going to create a for loop because we don't know the size during runtime. We can't assume it's always going to be this size or that size. I'm going to start at 0, position goes until courses dot length and position plus plus. Give me a second. I'm just gonna drag this over here. Okay. So now we're going through each one of them, and what we're gonna do is temp at position. We're gonna make it equal at courses dot position. So now we're copying all of those cells into this new cell. So every course that we had, we're gonna copy it into that other one. So give you an example. Let's say this only became, I want to erase a bit, but so let's say the size became 6 for some whatever reason. What I'm gonna do is I'm gonna copy this value into here, this value into here, and the rest is going to stay blank until they get filled by the next time. Right? If anyone has any issues about this, you need to let me know. Otherwise, you're gonna have issues later on. So I'm copying everything in there into my temporary array. And at the end of all this, when all the values have been copied, so here we're copying the values. We want to transfer, we're going to make the courses from our students. So the attribute, the field, we're going to make it our temporary one. So here, I'm going to say courses equals that temporary. Notice there's no position here. We're making the new pointer, the new address of courses equal that temporary. Right? And now the total courses is still going to be smaller than new course length. So now you could keep on adding, right? Does everyone understand this? This is an array and how we keep on making it bigger and bigger. It's a lot of work, but we got to do it. Someone has to do it. No one has any issues? Okay, we're going to make this a bit, well, we're not going to complicate it. We're going to actually make it something simpler. So part of those helper classes, let's go back to our main. Part of those helper classes, we also have these things called collections. And a collection is basically an array. A collection is an array which helps you actually manage an array. Okay, and really you don't have direct access to that array, but that array exists, and it's going to deal with increasing the size, it's going to deal with erasing stuff, it's going to deal with positioning, all those shenanigans that you have to deal with. And collections goes into two different sections. You either have a list or versus a map. And if we get time, we'll talk about both of them, but for now, it's fine. Okay? The first collection that we're going to talk about is an array list. And probably we're going to stick to array list and we move on later. So in this case, notice that when we create an array, because it's immutable, we had to do all of this work just to increase the size by a bit. Right? So rather than dealing with that thing, what we could do here, I want to actually comment it out. Rather than doing that is we could create an array list which takes, right here you have to specify the type. This is called templating. We'll talk about that in the future, hopefully. This is to specify that array list, the generic value, the generic type it could be. In this case, you have to mention what type it is. Okay, you can't intermingle different types. So in this case, we're making an array list of course. Right? You guys might have done the same thing, but you might have done it in vector and C++. So in this case, we need to import the library, Alt-Enter. Right? And again, we're going to just do new array list. And I'm going to say courses. Again, we probably don't need to do that, and that's pretty much it. Do I have unexpected token? What did I do? Oh, I forgot. I forgot to put the variable name. Sorry, talking at the same time is a bit confusing. So here we're gonna put courses, and we have that. Cool. So now we're creating the same array we did before, but it's encapsulated inside this class called Arraylist. And the cool part about this is going to give us a lot of functionalities which we don't have with the not primitive type, but with the default arrays. Right? And you'll notice over here it says, well, if you mention here, you don't really need to mention course here, so we could actually erase that if you wanted to, and it's still fine. Cool. No one has any issues so far? Now, the cool part about this class, let's go back down. The cool part about this class is we do not need to manage the size anymore. That's the cool part. So this whole part over here, we can erase. That's the first cool part about that. Second cool part is we don't need to manage the positions either. So we could just say courses, add, which course do you want to add? And you'll notice the IntelliSense, actually, let's do that one more time. Courses dot add. Notice that when you do the add, it's actually mentioning that you want to add a course here. The parameter is requires a course. And we're going to give it that specific course. So now we don't need to say at any specific position where we're adding the course. So we can erase that. And we don't need to keep track of our courses. Why? Because, let's go back up. Because this total courses is actually given to us inside this array list. It's given to us by, let's do it here just to test it out, courses dot by, where is it? By size, right? Control Q gives us, returns the number of elements in this list. And you'll notice there's a lot of functions that are useful to us. One of those functions is our array empty, right? Another function is get me that specific position if you ever needed to do that. Get, give it a position, right? And as you have add, you also have remove. You could specifically remove an index, or you could specifically remove that object that's given to you. So our student we could make it a bit more funky. So if at any moment we add a course to our student, we could at any moment public void remove a course. And that would automatically figure out which object equals this one inside the array list, and remove it for us. Right? Any questions? So this is pretty useful to know about, and if you wanted to, this would be a cool assignment to do for yourself. Create yourself an array list. Look at all the functionalities that you would have inside of an array list by doing courses dot, and look at all of these functions and see if you could actually write all of that. And they're not big, to be honest, probably will take you an hour. And this is something that the people before you, the early programmers and whatnot, they came in and they noticed arrays was not that useful to them. And they noticed that this keeps coming back and forth all the time. So they created these helper classes, and one of them being Arraylist. Right? And again, if you don't know how it works or whatever, you could always hold down Control, click on it, and you could actually read the code. Notice they have a counter, like we were doing, for when we add something. And then they have another function which adds that specific thing given to us, that element, that value, and it will try to add it, right? And if the size equals the length, right? We did the same exact thing. They want you to grow that array. So in this case, the grow is this. And again, you notice it's a lot of abstraction here where they're sending it all over the place. But the point is, it's doing exactly what we were doing, except now it's doing it all for us. So we don't have to think about it too much. And it's pretty well done because it's accepted by the community, and the community says it's okay for now. Right? Over time, changes happen, but for now, this is the perfect code. Cool? So let's try this out. So we could remove courses, we could get that, and let's create another function, public void print courses. Right? In this case, we're gonna just go ahead through all of our stuff. So we're gonna create a for each. So we got course for each course in our courses. Right? I hope this makes sense. We want to print out the course name, get name. All right? And maybe at the top we'll say currently taking the following courses. And over here we could add a little \T for a new tab, make it look a bit cleaner or something. So let's go back to our main. And inside main we're gonna do, let's say we're gonna create a student. Actually, I already created a student down below. Let's just go and copy paste that. Take off these things. Student 1. Actually, let's go ahead and copy these two. Right? So we have student 1, which is Akshay, and there's course 1 Java that it's taking, and could be another course 2 and a course 3. And this one is C++, and this one is I don't know what else you guys have. Let's say web development or something. Right? And inside student 1, we do student 1 add course, and we add course 1. Student 1 dot add course, and we do course, let's say 3. Okay, and again, you would have probably done this through asking the user what he would like to do, and depending on his choices, you would do these lines. Right? Same thing for these. And now, if we wanted to remove something, it's just as simple by just doing remove course 3. And maybe go ahead and add student 1 dot add course 2. Right, let's run it out. And actually at the end of this, we're going to do student 1 dot print courses. So let's see what it shows. So where was our thing? It's right here. Notice it prints out Java 1 and C++. Java 1 and C++. So that's course 1 and course 2. Notice that course 3, even though it's been added, it got removed right away. And then we added course 2. What if we added multiple of the same thing? So let's say course 2, I added 3 times. Run this. Right? So in this case, it still doesn't make a distinction that C++ has already been there. And this is not its job, right? Because we're using Arraylist. It's not a unique identifier. There's different types of collections. So far, we've only seen Arraylist, which is not about uniqueness, is more about having an array that's being managed by someone else. Cool? Any questions? So Arraylist is going to be important. You're going to be using it throughout the semester. So knowing that Arraylist exists is going to help you out dealing with lists of things. And the more you use it, the better you understand it, and so forth, so on. So, and this is important. Okay, so a couple of functions to use inside Arraylist would be, well, there's the size. You could get something at an index, so the normal way you would do it, right? You could add an object. You could remove an object. You could also add or remove a position, or remove position. So either way should work, okay? You could do clear. So this removes all of the elements in there. Okay, there's other functionalities, but I think these should be enough for you to get you going and get the initial set of things you need from it. Okay? There's other stuff. You should check it out. Really check it out. Okay. So we went through an array list. We did those few things. So we got to remember that there's two things that's going on. There's actually, this shouldn't be list. This should be collection. There's two major stuff going on. One is collection. One is map. And if we get time, we'll go through that. And inside collection, so inside of collection, there is the array list that we just seen. There is other stuff such as set, and maybe also we would see queue. Okay, and these are important because each one of them, again, it's an array. It holds out more than one item, but the difference is how they hold out those items. So far we noticed that array list is not unique, right? It contains the same object multiple times. Is that a correct thing to do or not? This is dependent on our list, right? It's not all people. Sometimes you want to have the same thing. Let's say how many times someone scored a home run during a game. Each time you score a home run, add it to this list, right? The guy could have scored a home run 10 times. You want to add it 10 times. So this is something to remember. Okay, set queues and maps. You could look into it yourself. Let's go ahead and talk about another helper class, and that's going to be our last thing for today. The other helper class is collection itself. So let's actually come down here for a second. If we type in collection over here, collections actually, it gives us a lot of static functionalities, which helps us do multiple things. Okay, and one of the best things would probably be we could let's say we could sort something. So if we start typing sort, but in this case it's checking if it's been sorted, the check sort. But notice over here it's actually going to sort our list for us. Right, so let's try this. Let's go ahead. I want to just take this out for a second. Refactor, extract method. Let's say, I don't know, array list. Okay. Comment that out. So now let's talk about collection. So let's say in this case, I'm going to create a array list. By the way, before we move on, I just want to show you something. Let's say if I had a string array, right? And we had a two-dimensional array. We talked about this. If you don't know about it, go back to the older videos, check it out. So in this case, we give it a size, and we give it a size. And if we wanted to create an array, again, remember the way to read this is actually to say an array of a string. So read it backwards. It's much easier. So this is an array of arrays of strings. If we wanted to create that inside our collections, well, we could do it too. Let's say inside the array list again. We just have to say, well, it's an array list of strings. So in this case, we would say array list of strings. And over here, we would say, let's say, a array list of array, I don't know, whatever it is, equals new. Cool, and we don't need this. Right? It's really funky because now we have an array list of string. And then this is the same thing by saying an array of a string. And again, you could go infinitely as you want. But do you want that or not? But I'm putting it out there. Okay? So If you have a question, stop me. Don't make me go further. So let's call that one two-dimensional multi-lists. Let's say that. It's, I don't know, whatever name you want to come up with. Okay, let's go back to our collections, our helper class here. I want to show you something funky. So we're going to create another array list. And this time it's going to be about strings, right? Because strings is an easy way. And let's say this is the names. And we're going to create an array list. And really it's not going to have anything, right? So I'm going to put your names in there at whatever order I see inside the participants currently. So actually I'm going to put them in reverse, or I'm going to put them in random order. So I'm going to add a bunch of times. Okay. And let's go ahead. And let's say we have Mirage. We have Manjot. We have Akshay. Sorry if I might misspell your names. Feet. Let's go back down. Scope 2. Parf. Amita. Abin. Javid. Sorry, Javid. Geo. Sai. Or let's say just Sai. Blah blah blah. MT. I don't know whose name that is. Niraj we already did. Okay. And Parampreet. And Parf I think I already did. Scopy I did. Manjot I think I did. Yeah. Parampreet, Abin. And at the top we have N Janan. And Amita I did. Abin. Okay. I think I got everyone. Now let's say I added this list and then I wanted to print this list. Again, we'll do a for loop. In this case, for each string, so for each name, inside my list of names, right? Notice the singular and notice this one is plural. So when I highlight it, it's showing you the array. So for each name inside that array, I want to print that name. And now if we run it, you notice it's nothing fancy, it's the order you put it in. So whatever order I came in is the order that's going to finish. So starting with Niraj. There we go. So starting with Niraj and it ends with Anjana. Right? Now, the cooler part is we're giving a lot of helper classes again. So this helper class is called collections. And what collections could do for us is it could sort things for us. And the sort, we could customize it later. But for now, we're going to say, just sort it out the normal, natural way. And let's see what the result is. Actually, run main. And if you notice this time, because it sorted everything, it starts with the letter A, and it keeps going down until the last person, which is M. Huh, that's a bit wrong, no? Sorted A's, S, isn't M before S? I think there's a little problem here. I don't know what kind of sort it's using, but you notice that it started out sorting some stuff. For some reason here, it's messing up at the last bits.
It's small letter, sir. Second division.
Ah, thank you very much. Great perception. So he noticed that it's capitalization first, and then it went for the small letters, right? Thank you very much. So if I make this all capital, it will actually do it correctly. And this is good because I don't know if he knew that the difference between capitals. I guess he did. Inside the computer, this is why knowledge is powerful. Uppercase and lowercase are two completely different characters, right? sometimes we miss it from our attention, but the more you know, the more you get to understand why that happened. And in this case, he knew better because he knew that lowercase and uppercase are completely two different characters. Cool? Any questions? So we could do the same thing for numbers and etc. And he does a lot of things for us. There's other functionalities. We could collections. There's sorts. Just go through it. Searching through your list. This could be useful at some point. You could copy that list to another one. You got to make sure that you don't copy a address because that's not the same thing. When you do this copy, it's going to copy, this is something they call a deep copy. They're going to copy the values and not the address of the array. So this is something to think about. We could talk about it. You'll get an assignment, which you'll see. Empty out the list, do this to it, check it out. It's a lot of cool stuff. Yeah. Or if you wanted to convert that list into a different type of list, so from Arraylist maybe to a map, or maybe to something else, or to get the maximum or the minimum from that list, this is something to check out. Maybe reversing that list. Let's see what that does. So this made it alphabetical from A to Z, and when we make it reverse, it makes it Z to A, right? So there's a lot of cool functionalities already built in. And again, we don't want to reinvent the wheel for every little bits and pieces. At the beginning, at your levels, we kind of want to learn all these functionalities, all these tools better, because the better we understand it, the better we could use it. The same way he caught on to the capital and to the lowercase. But we don't want to come down and rewrite everything just to be able to create an application for the teacher that takes 5 minutes, right? So this is something to think about. Okay, and as always, if we want to learn, we could hold down Control and just click on, let's say, how does it sort, let's say. Click on that, and you could go through the list of things. This is most likely how they sort, right? And again, they're calling a lot of functionalities, and it's becoming a bit more abstract and a bit harder to read. And this is not where we're at yet, right? We'll come back to this maybe not with me, with my class, but within a year-ish. Cool? So the last one is collections. Collection as a helper class. So it could sort for you, it could reverse for you, it could copy, a deep copy, and this is going to see something called deep copy and something else called shallow copy. And this is important to understand. A shallow copy, we're gonna end it after this, so make sure you understand this part. This is something, an error that keeps popping up all throughout work, and usually this shouldn't be an error that you'll get this when you're junior level, but you shouldn't get this as you go further in your career. Okay, so what we're gonna do is, so let's say we have a stack. Actually, let me draw a bit here. So we have our stack, and we also have our heap memory. And somewhere along this way, there's an array somewhere here. Let's say this list is here, and the same list is what we want. We want to create a copy. So this is our variable A, and our variable A points to this arrow. We have another variable A. Actually, let's say inside this, there's 1, there's 2, there's 3, and there's 4. Okay, so inside this array, there's 4 values. We want to copy these exactly into this new variable, which we call B. Right? Now, if we do a shallow copy would be basically saying A equals, B equals A. This is a shallow copy. And why is it a shallow copy? Because the moment we do this line, this B is not going to have its own array. It's actually just going to be pointing to the same array, the same collection. And this is bad. Why? Well, because if at any moment inside B, I go ahead and I change, let's say, position 1, position 0 to, let's say, 3, well, it will change it for A and B together because they're both pointing to the same thing. Does that make sense? Changes for both arrays, A and B. Now, in a deep copy, this is what's so interesting, is it's not gonna, in a deep copy, what it's gonna do, it's gonna copy exactly, so let's say, oops, it's not letting me, wow, okay. So let me just rewrite this. In a deep copy, what it does, it actually copies the values and gives you, so let me delete this one, and it gives you that new array. So now if you do any modification, it will only affect you and not the other variable that already also exists. Cool? That's the difference between a deep copy and a shallow copy. And this could also come out as an interview question. So this is something to note. So copies values and gives a new location in memory. New location, a new array location in memory. Okay, so this is important. So deep copy it's not only for arrays, it could have been for an object, it could have been for anything. When you make it equal to something, you're just giving the position. And again, this is what's so important about the heap and memory and references and all that. This is just copying the address of where the object exists. We never actually have the objects in our hands. So when you make a shallow copy, you're basically giving two people the keys for the same house, right? So now A and B are going to go in the same house and they're going to say, oh, who are you? Why are you living in my house? Well, in a deep copy, what we're doing is we're copying the house and giving one key to a different house to one of them and one key to a different house to the other one. So now they're both living in their own little world. Cool? Any questions? Cool. So this becomes more interesting as we go along. So if you have no more questions, we're kind of at the end of me talking for 8 hours straight. Maybe you're fed up to hearing me from some people's perspective. Notice these terms, again, the terminology is important. You don't need to fully grasp it yet, but you need to start trying to understand it as best as you can. And you're going to be using this terminology, and it's important to understand the terminology because, let's say in the case of another pandemic happens, the only way we could communicate with someone else is through the phone or through, let's say, emails, etc. If you cannot communicate correctly or perfectly, you would have to keep saying, hey, can you connect to my screen, look at my stuff, etc. People don't have time for 5-year-olds. They have their own kids at their house. So the terminology is going to enable you to communicate better, to explain what you need or what the issue without requiring to draw it for the person. And I'm drawing it because, one, it's your first time seeing this, and I'm pretty sure there's a lot of parts of it that's still foggy as a good word. Okay? So it's important, this terminology, it's something to start seeing it and understanding, oh, I remember that shallow copy, oh, I remember that deep copy, right? Because when, let's say, if I use collections, and I do, let's say, copy, do we have a copy? Yes, we do. And we do control Q on this. Let me erase the board here. And we do a control Q. So copy. Copies all the elements from the one list into another. After operation, the index of each copied element in the destination list will be identical to the index of its source list. Blah, 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 blah. Okay, in this case, it doesn't say anything about shallow or deep, right? In this case, they're trying their best their best to not put in any terminology in there. But you're going to notice a lot of these documentations, most of them, they won't explain it all this. They would just say, this is a shallow copy, this is a deep copy. And that's all they're going to say, nothing more. Why? Because the word is that definition that we just read, the deep and the shallow. Okay? So they don't need to write more as an example. Cool? So one more time, any questions? All right, so let me stop the video.